A pleasant day to each and every one. We are a group of faculty members from the Technological University of the Philippines Taguig campus, a collaboration between Computer Technology Department and Basic Arts and Sciences Department. We are headed by our project leader, Mr. Nestor Valdez, our study leader, Miss Maria Leonora Teresa Aguilar. Together with us is Miss Terili Pascones, Mr. Ivan Riancero, and yours truly, Maria Chloe Ann M. Sarmiento. I will be presenting to you our study entitled Electrochemical Sensor for Detection of Toxic Gases, a trainer for environmental science and chemistry subjects. We teachers sometimes are having a hard time getting our students participate in the class, most especially when teaching science subjects, right? Teaching science requires imaginative and creative ways to involve the students in learning even the most challenging topics in school. Students need to learn a blend of challenging facts, problems, and practical experiments. Laboratory concepts, theory, and skills acquired should not remain only in the classroom, must be put in practical use and real life activity. Laboratory courses increases student satisfaction, self-efficacy, and ensure academic success through incorporation of team-based learning, development of mini-grant research proposal which could develop their metacognitive skills. According to a study reported by University of Chicago, students who physically encounter science concepts, principles, and theories comprehend more profoundly and score higher on exams. Educators should clearly understand and respond to the students' individual, emotional, and cognitive profiles, and wisely choose a pedagogical method and techniques which are suitable for students and their opportunities to interact, encourage, and inform all types of learners at an optimum level. These are the objective of our study. First, to design and develop a trainer that uses electrochemical sensors to detect gases. Second, to test and evaluate the trainer in terms of its functionality, aesthetics, workability, durability, safety, and efficiency. Third, to be able to use the trainer in class discussion and experiments. The development of the electrochemical sensor will be used for the detection of various toxic gases during class discussion, and the participation of students will be highly solicited for the absorption of knowledge through first-hand approach learning. The process variable will be based on the ADDIE model analysis, wherein we have to assess the situation to understand the gaps we need to fill in. In our case, teaching challenging topics as productive as possible using first-hand learning approach. This also includes the identification of materials to be used and procurement of materials. Next will be the design, wherein we finalize the design of the trainer with block diagram, hardware development, and program or system development. Another D for development, wherein fabrication of the prototype will occur, assembly of all components, and installation of the program. I for implementation, wherein we will be having a trial testing to see whether the trainer works based on our requirements. And lastly, E for evaluation, we will be seeking the help of some experts in evaluating the different components of our trainer. Establishing the design, identifying materials, sourcing, and manufacturing are all part of the project's conceptualization. The design should be in line with the study's objectives and meet the criteria of prototype research. The figure on the screen is the design of the trainer. The main concept of the design is to be used as an educational trainer and for experiments or laboratory experiments in school. It is designed to be user-friendly so that students can easily adjust on how the trainer works. An Arduino-based embedded module is also used to perform continuous measurements of the concentration and level of organic gases so the standard preventive measures can be taken when necessary. Because the resistivity of the Arduino sensor is inversely proportional to the concentration level of the gas, the higher the concentration level of the gas, the greater the resistance drop. The difference between the initial resistance values of the Arduino sensor in clean air and the resistance after contact with gases is measured in this work. The higher the gas concentration, the greater the change in resistance value. This is the project system flow. The electrochemical sensor is an embedded system in a computer system with real-time parameters that works in a conjunction with a mechanical or electrical system to perform a specific function. It starts with the inputting of the cell phone number of the receiver, followed by the emission of the gas, which will be detected or not detected by the sensor. And lastly, it will show the result on the LCD screen along with a text message to be received by the number saved. The program is made up of various microprocessors and sensors that are used to perform computational tasks. This conservative system can form a long-term monitoring and control system for all measurable parameters. This embedded system can be made smaller, lowering the product cost, which could help in the development of the trainer. The electrochemical sensor was developed with the following qualities. It is programmable, it can send text message, it is sealed for no leakage, and it can detect or withstand gases. The trainer is evaluated using the criteria of 5-point scale in terms of functionality, aesthetics, durability, and workability. A Google form is used to assess the electrochemical sensor trainer, and 54 experts from different industry answered the evaluation through the link sent to each one of them. Based on the data gathered, an average of 4.47 rated the trainer in terms of its functionality, which shows that the trainer ease of operation, provision for comfort and convenience, and user friendliness is very good. Functionality is important in a prototype to be used in a classroom setting, to be able to teach the students without having a hard time operating the trainer. On the aesthetic side of the trainer, an average of 4.27 rated the trainer on its color appeal, attractiveness of design, and appropriateness of size. It shows that aesthetics was rated very good. Aesthetics will be used not just to attract the attention of students during class meetings, but also to be able to commercialize this trainer to education sectors in the future. Next would be the evaluation of the expert on the trainer's workability. An average of 4.5 signifies very good in terms of its availability of materials, availability of technical experts, and availability of tools and machines. Availability of the mentioned would be easier for the researcher to develop and maintain this prototype. And in terms of its durability, an average of 4.43 rated the trainer in terms of the quality of materials, quality of workmanship, and quality of the design. It shows that the trainer's provision for its durability is very good. And lastly, an average of 4.3 rated the trainer's safety in terms of its provision on the absence of toxic or hazardous materials, absence of sharp edges, and provision of protection devices is very good. This shows that the trainer developed with a design that is not harmful for both the educator and the students. To sum it all up, the average evaluation of 54 experts of the components of the electrochemical sensor was exceptionally very good. For the conclusion of our study, the electrochemical sensor was successfully fabricated, assessed, and evaluated by experts. It also satisfied the following requirements: a programmable device, material used can withstand gas, material used are low cost, and it conforms with the main purpose of the study. And here are the references of our study. Thank you everyone for listening. God bless us all.